Good evening, and welcome back to SleepWise. Tonight, we drift beneath the quiet river of stars that humans have watched for thousands of years. A pale band of light stretched across darkness, so soft and distant that it can seem almost like breath on glass. This is the Milky Way, our home galaxy, the great luminous city in which our sun, our planets, and our small blue world all make their slow and ordinary rounds. And before we go farther, if SleepWise helps you unwind, follow the channel and share it with someone else whose mind also stays awake a little longer than it should. For most of human history, the Milky Way was not understood as a galaxy at all. It was simply there, above deserts, oceans, forests, and quiet rooftops. A glowing path crossing the night. Different cultures gave it different meanings. Some imagined a celestial river, others a road for souls, a trail of smoke, spilled milk, crushed pearls, or light brushed across the heavens by unseen hands. Long before telescopes, people knew it was beautiful. Long before science explained it, they understood it was worth looking at slowly. One of the first quiet facts to carry into the night is this: the Milky Way is not somewhere else. We are inside it. When you look up at that hazy band, you are not looking outward at a distant object the way you might look at Mars or Jupiter. You are looking through the crowded disk of our own galaxy from within, edgewise, like sitting inside a vast lantern and noticing the glow thickest along its widest part. That soft band appears because the galaxy contains an enormous number of stars, far too many and far too distant for the eye to separate one by one. Their light gathers into mist. Between them lie lanes of cosmic dust, dark drifting clouds that block some of the glow and give the Milky Way its textured, marbled appearance. So even to the naked eye, the galaxy is not a smooth stripe. It is bright in some places, shadowed in others, a hidden structure only partly revealed. Another gentle fact is that the Milky Way is easier to see from truly dark places than from modern cities. For most of our ancestors, it was part of ordinary night. Now, for millions of people, artificial light has washed it from view. Entire generations have grown up beneath skies so bright that the galaxy of their birth is missing overhead, not because it has gone anywhere, but because our lamps, towers, roads, and windows speak louder than starlight. And yet, it is still there, arching silently above the world, patient as ever. Tonight, we begin with that simple idea. The Milky Way is our galactic home, seen from the inside as a river of unresolved stars and shadowed dust, ancient to human memory and vast beyond instinct. The world slows, and so do we, as we take our first small step into its light. As the old story slowly gave way to observation, the Milky Way began to change in human thought. It was no longer only a river or a path or a veil, but a place. Telescopes revealed that its pale glow was made of stars, more stars than the unaided eye could ever count, layered so densely that distance turned them into haze. What had seemed like a single soft brushstroke across the sky was, in truth, a vast congregation of suns. The galaxy we live in is known as a barred spiral galaxy. That phrase may sound technical at first, but its shape can be held gently in the mind. There is a bright central region, a broad disk, long curving spiral arms, and crossing the middle, a straight bar of stars. If you could rise far above it and look down from some impossible stillness, you would not see a perfect pinwheel, crisp and symmetrical like a diagram in a school book. You would see something grander and softer, a structure with pattern, yes, but also variation, density, motion, and age. The Milky Way is not made only of stars. This is one of the quiet truths that makes galaxies feel more alive than simple collections of lights. Between the stars drift enormous clouds of gas and dust. In some places, that material is thin and scattered. In others, it gathers into darker lanes and denser regions, where gravity slowly draws matter together. Stars are born there, not suddenly, but over long spans of time, as cold clouds collapse and begin to glow. So the galaxy is not merely a container of ancient light. It is also a workshop, still shaping new suns in its darker rooms. Around the visible galaxy lies something stranger still. Astronomers have learned that the stars and gas we can see do not account for all the gravity the Milky Way seems to possess. The galaxy behaves as though it is wrapped in a much larger halo of unseen matter. This invisible presence is called dark matter, not because it is simply unlit, but because it does not appear to interact with light in the ordinary ways. It reveals itself mostly through gravity, through the motions it allows, the structure it supports, the hidden weight it seems to lend. And so the Milky Way is already more than the eye first suggests. It is a barred spiral galaxy of stars, gas, dust, and invisible mass, all bound together in one vast rotating system. It is not fixed like paint on a ceiling. It moves, it turns, it evolves. Its shape is not an ornament, but the temporary expression of forces working over billions of years. Perhaps that is part of why it calms the mind. The galaxy is immense, but not chaotic, complex, but not hurried. It holds brightness and shadow, structure and mystery, birth and age, all at once. And somewhere within that quiet architecture, in one modest region among many, our own star continues to circle with patient obedience, carrying us with it through the dark. To speak of the Milky Way is to speak sooner or later of scale, and scale in astronomy has a way of softening the ego. The galaxy is so large that ordinary units begin to fail almost immediately. Miles become awkward. Kilometers become small. Even the distance from Earth to the Sun, which feels enormous in daily life, becomes only a local measure once we step into galactic space. So astronomers often speak in light years. The distance light travels in a year, because even light, moving faster than anything we know, needs time to cross the galaxy. The Milky Way is roughly 100,000 light years across, perhaps a little more depending on where one measures its faint outer structure. That means if a beam of light set out from one side of the main disk and traveled steadily across to the other, it would need about 100,000 years to make the journey. Human empires rise and vanish in far less time than that. Languages are born, divide, and disappear. Ice advances, retreats, and returns. Yet for galactic distances, even such spans are simply part of the background. Its thickness is more modest, though still immense by human standards. The thin disk, where many of the stars, gas clouds, and spiral features are concentrated, is only a few thousand light years thick. This gives the Milky Way a kind of flattened shape, more like a disk with a central swelling than a perfect sphere. And that flattening matters, because it helps explain why the galaxy appears in our sky as a broad band. We are embedded inside that disk, looking along it, through its crowded plane. As for the number of stars it contains, there is no perfectly final count. The total is so large and many stars so faint that astronomers estimate rather than tally them one by one. But the estimate is staggering enough. The Milky Way likely contains hundreds of billions of stars. Some may be larger and hotter than the sun, burning blue and briefly. And stars are only part of the story. The galaxy also contains star clusters, nebulae, stellar remnants, black holes, drifting dust, and great reservoirs of hydrogen gas. It holds ancient stars formed early in cosmic history, and younger stars born more recently from recycled material. In that sense, the Milky Way is not only large in space, it is layered in time, built from generation after generation of matter, reworked by gravity, fusion, and collapse. When people say we live in a vast universe, the phrase can sound almost worn by repetition, but the Milky Way alone is enough to restore its meaning. One galaxy, one among many, stretches across distances so large that light itself needs ages to cross it, and contains more stars than a human mind can comfortably picture. The world grows quieter when measured against such things. Not smaller in importance, perhaps, but gentler in proportion. And where, within this immense and softly turning system, do we live? Not near the center, as earlier ages sometimes imagined, and not on some privileged edge looking inward like spectators. Our sun rests in a smaller structure called the Orion Arm, or more precisely, the Orion Spur, a minor spiral feature between two larger arms of the galaxy. It is a modest address, neither especially crowded nor especially dramatic, a kind of galactic neighborhood where the traffic of stars is present but not overwhelming. We are about 26 to 27,000 light years from the galactic center. That distance is worth lingering over for a moment. It means the heart of the Milky Way, though central to our galaxy's structure, is still very far from us. Its denser star fields, its greater brightness, and its hidden black hole all belong to a region we do not inhabit directly. We live farther out, in a quieter part of the disk, where the sky is calmer and the conditions may have been favorable to long stretches of planetary stability. This is one of the lovelier facts about our place in the galaxy. It is ordinary. There is something restful in that. Earth circles an ordinary star. That star lives in an ordinary region of one galaxy among countless others. We are not seated at the center of anything grand, and yet this unremarkable placement may be part of what allowed life the time it needed. Too close to the galactic center, and the environment may be harsher, denser, more disturbed by radiation and gravitational encounters. Too far out, and the chemistry of star and planet formation may differ. Here, in this quieter suburb of the Milky Way, conditions seem to have been kind enough. The sun itself is only one traveler among many. It carries the planets through the galaxy while also holding them in its own much smaller family. So while Earth circles the sun once each year, the sun is also making a far greater journey around the Milky Way. We are never still, even in sleep. We move with layers of motion at once, like a passenger crossing a room on a ship that is crossing an ocean on a world that is crossing a galaxy. If you could somehow mark our position from above, it would not look impressive. There would be no glowing sign, no highlighted point. Only one star among hundreds of billions, tucked into a lesser arm, partway out from the center. Yet from that modest location came poetry, mathematics, music, myth, biology, instruments, observatories, and the curiosity needed to understand the larger structure around us. Perhaps that is the tender balance astronomy offers. It lowers us, but it does not diminish us. It reminds us that we are small, but also that small beings can notice astonishing things. Tonight, our place in the Milky Way is neither central nor grand, but quiet, stable, and sufficient. A small room in a very large house, with one window open to the stars. Because we live inside the Milky Way, our view of it changes as Earth makes its yearly path around the sun. This means the galaxy is not presented to us in the same way every night of every season. At some times of year, the richer central regions of the Milky Way rise into better view during the darker hours. At others, different stretches of the galactic band are more prominent, or the best view arrives late, after many have already gone to bed. The galaxy is constant in itself, but our angle into its light is always shifting. This is why stargazers speak of Milky Way season. In different parts of the year, different portions of the galactic disk stand higher in the sky at convenient times. In the northern hemisphere, the bright and textured core region is often most admired in the warmer months when it arches upward on darker nights. In the southern hemisphere, the Milky Way can appear even richer and more dramatic in some seasons, because our southern skies offer a better view toward the galaxy's central direction. Neither hemisphere owns the galaxy, of course, but each is given a somewhat different version of the same home. The moon matters too. A bright moon can wash out fainter stars and reduce the contrast that makes the Milky Way so haunting to the eye. On moonless nights, especially far from towns and highways, the band can appear almost shockingly alive, textured with knots, brightness, and shadow. In places of exceptional darkness, it can even cast a faint impression on the landscape, not enough to read by, but enough to feel that the sky itself is participating in the ground below. And then there is the modern condition of artificial light. Street lamps, billboards, towers, parking lots, apartment windows, industrial sites, all of them lift a pale haze into the atmosphere. Light pollution does not erase the Milky Way. It simply outshouts it. This is one reason the galaxy has become, for some, less a nightly companion and more a destination, something to be traveled toward in deserts, highlands, islands, or remote valleys. To see the Milky Way clearly now often requires intention, a kind of small pilgrimage back into darkness. Today, many live under skies so altered by our own brilliance that the larger brilliance above is hidden from memory. Yet, when people do finally see it clearly, the reaction is often the same: quiet, surprise, a slowing of thought. It feels both unfamiliar and strangely remembered. So another fact for the night is this: the Milky Way is not only an astronomical object, but a seasonal and earthly experience shaped by hemisphere, moonlight, weather, and darkness itself. The galaxy does not perform on demand. It waits for clear air, dark skies, and patient eyes. And perhaps that is fitting. Some things are better encountered not all at once, but when the world has dimmed enough for them to return. The Milky Way, when seen from a dark and patient place, can look almost like cloud or smoke, as though some pale substance had been brushed across the sky. But that softness is made of precision. It is built from stars and from the limits of the human eye. What appears to us as mist is often the combined light of countless distant suns, so numerous and so tightly packed along the galactic plane that the eye cannot separate them into individuals. Their brightness gathers, and the galaxy becomes a glow. This is one of the gentlest facts in astronomy. The Milky Way is not a single object suspended neatly above us, but a layered field of stars viewed from within. Some are relatively close and bright enough to stand apart as points. Others are so distant that they merge into faint grain and haze. When you trace the brighter band of the galaxy across the night, you are sensing density, not fog. You are looking through deeper and more crowded stretches of our stellar home. Even a small pair of binoculars begins to reveal this secret. Regions that seemed milky and smooth suddenly break into sprays of individual stars. A modest telescope reveals more still, as though the sky had been withholding its finer handwriting until someone leaned closer. What the naked eye calls a blur turns out to be structure. What seemed like celestial dust becomes population, distance, and number. Yet the galaxy does not appear evenly bright, and that unevenness matters. Along the Milky Way are dark lanes and irregular gaps where cosmic dust blocks the light of stars beyond. These are not empty places. In a sense, they are full places, dense with tiny grains of matter rich enough to obscure what lies farther back. The result is that the galaxy often looks marbled, streaked, and textured, as though shadow itself had been woven into the light. Some of the stars within the Milky Way are young and hot, shining with a bluish intensity. Others are older, cooler, redder, and dimmer. Some are giants, nearing the last chapters of their lives. Others are small, durable stars that may burn for spans far longer than our sun ever will. The galaxy's light, then, is not just abundance. It is diversity. The glow is made by stars of different ages, sizes, temperatures, and fates, all contributing their part to the long silver band. To lie beneath the Milky Way is to witness an illusion that is also a truth. It looks soft because we are limited, and beautiful because those limits still allow us to perceive the whole. The mind does not count billions of stars one by one. It receives them as atmosphere, as radiance, as depth. And perhaps that is enough for the night. The galaxy does not ask to be totaled before it can be admired. It only asks that we look long enough to notice that even its blur is made of suns. Between the stars of the Milky Way lies a quieter world, one that does not shine with the same easy confidence. It is the world of gas and dust, of cold clouds and hidden beginnings, of regions so dark that they seem at first glance to be absences. But these are not merely the spaces between brighter things. They are part of the galaxy's life. Without them, many stars would never form, and much of the Milky Way would be little more than a slowly aging archive of old light. The great raw material for new stars is found in enormous clouds, especially clouds rich in hydrogen, the simplest and most abundant element in the cosmos. In some regions, this gas is thin and diffuse, spread over immense distances. In others, gravity helps gather it into denser and colder structures called molecular clouds. These can stretch across dozens or even hundreds of light years, vast enough to make our solar system feel like a particle in a room. Inside such clouds, the process of star birth begins quietly. Gravity pulls matter inward. Denser pockets form. Over time, some of these knots become compact enough that their cores grow hotter and hotter under pressure. At first, there is no star, only a gathering. Then, if enough mass collects and conditions are right, the core becomes hot enough for nuclear fusion to begin. A new star is born, and a region that was once dark and cold begins to produce light. This is why nebulae hold such a special place in astronomy. A nebula is not one single kind of object, but the word often points us toward these dramatic regions of gas and dust. Some nebulae are stellar nurseries, places of formation. Others are the remains of stars that have shed or blasted away their outer layers. In both cases, they remind us that the galaxy is not static. It is continually recycling matter, turning old stars into enriched material and enriched material into new stars. Dust, though only a small fraction of the galaxy's mass, plays an outsized visual role. Tiny grains of carbon, silicates, ice, and other materials drift through interstellar space, scattering and absorbing light. They dim the stars behind them, redden what does get through, and in some places create the dark rifts that cut across the Milky Way's glow. They hide the very regions where transformation is underway, like curtains drawn across workshops in which something delicate is being made. And so the galaxy is not only a field of finished stars, but a place of preparation. Far beneath the visible shimmer are cold reservoirs, shadowed chambers, and patient accumulations of matter waiting for gravity to do its slow work. Tonight, it is enough to know that some of the darkest parts of the Milky Way are not signs of emptiness at all. They are signs of making, of concealment before emergence, of light still learning how to begin. If we could somehow rise above the Milky Way and look down upon it from far beyond its rim, we would see one of its best known features: sweeping spiral arms winding outward from the central regions. These arms have become part of the familiar visual language of astronomy, graceful and curling, almost floral in their balance. But like many beautiful things in science, they are often misunderstood. The spiral arms of a galaxy are not rigid structures turning like the blades of a fan. They are something subtler. A good way to think of them is as regions of higher density moving through the disk, places where stars, gas, and dust become more concentrated for a time. Material enters these regions, lingers within their crowded conditions, and then moves onward. The arm is less like a solid object and more like a traffic pattern, a long-lived wave in which matter gathers and then disperses. This helps explain how spiral structure can persist even though stars at different distances from the galactic center orbit at different speeds. Within these denser regions, clouds of gas may be compressed, making star formation more likely. That is one reason spiral arms often appear decorated with young, bright stars and glowing nebulae. The arms are not the only places where stars exist, of course. Stars are everywhere throughout the galactic disk. But spiral arms tend to be especially rich in the ingredients and circumstances that make new stars easier to notice. They are active neighborhoods, luminous not because they own all the stars, but because they so often host the youngest and brightest. The Milky Way has several named spiral features, including the Perseus arm, the Scutum Centaurus arm, and the Sagittarius arm, along with smaller structures and spurs. Our Sun lives in the Orion spur, a more modest branch between larger arms. From within the disk, mapping this arrangement is difficult. We do not enjoy the clean outside view that artists place in books. Instead, astronomers piece the shape together through radio observations, infrared light, measurements of gas clouds, and the positions and motions of many stars. There is something quietly humbling about that. We inhabit a patterned structure that we cannot step outside to inspect directly. We understand it by inference, by patience, by assembling fragments into form. That, too, is part of the Milky Way's lesson. We do not always receive the whole from one vantage point. Sometimes we learn where we are by tracing motion, listening through dust, and accepting that clarity may come in pieces. So the spiral arms are real, but not solid. They are organized, but not fixed. They guide gas, nurture star formation, and lend the galaxy much of its familiar beauty while remaining more fluid and subtle than the diagrams of childhood might suggest. In the Milky Way, even structure is a kind of movement, and even movement can look from a distance like grace. As our attention moves inward from the quieter suburbs of the galaxy, the Milky Way begins to change in character. The stars grow more crowded. The light becomes thicker. Distances that already felt immense now gather into an even denser architecture around the central regions. This inner concentration is known as the galactic bulge, a swollen and busy heart of stars that rises above and below the thinner disk like a lantern glowing through layers of haze. The bulge contains many older stars, some of them among the more ancient populations in the galaxy. Their presence gives the central regions a sense of age, as though the Milky Way keeps some of its oldest memories close to its center. There is also a long bar of stars crossing the inner galaxy, an important feature of the Milky Way's structure. From the outside, it would help define the galaxy's form. From where we are, buried in the disk and separated by great lanes of dust, it is much harder to appreciate directly. This is one of the great visual frustrations of galactic astronomy. The center of our own galaxy is partly hidden from us in visible light. Between Earth and the core lie dense clouds of interstellar dust that absorb and scatter starlight. If dust were not there, the central Milky Way would likely appear even more brilliant and crowded to our eyes. Instead, much of that inner light is veiled, and the galactic center becomes something we sense imperfectly, a bright region with parts concealed behind dark curtains. That concealment is why astronomers rely on more than ordinary visible light to understand the center. Infrared light can pass more effectively through dust, and radio waves reveal structures and motions that optical telescopes alone cannot show. Slowly, with these other windows, the inner Milky Way becomes less of a silhouette and more of a place. Dense star fields, turbulent gas, energetic events, and the gravitational signatures of something extraordinarily massive at the core. When we look toward the constellation Sagittarius, we are looking roughly toward that central direction. The richest parts of the Milky Way in the night sky often lie there, especially from dark southern or low-latitude northern locations. Even through dust and distance, the center announces itself by abundance. The star clouds thicken. The glow becomes more elaborate. The galaxy seems to gather itself into something richer and more mysterious than the quieter stretches farther outward. There is a certain tenderness in the fact that our galaxy's center is both present and obscured. We belong to it, yet do not see it clearly. We orbit it, yet know it through veils. Perhaps that is fitting for a story told at night. Not everything must be fully visible to be real. Some parts of the Milky Way meet us as brightness behind shadow, as crowded light filtered through dust, as a promise of deeper structure just beyond ordinary sight. At the hidden heart of the Milky Way lies one of its strangest realities, a supermassive black hole known as Sagittarius A, usually spoken more simply as Sagittarius A. It sits near the galaxy's center, about 26,000 light-years from Earth, and contains a mass of roughly 4 million suns. That number is difficult to feel all at once, but its meaning is plain enough. Something extraordinarily compact and powerful rests at the core of our galactic home. Black holes are often imagined as cosmic vacuum cleaners, swallowing everything around them in a frenzy. But the truth is calmer and more exact. A black hole does not reach out like a hand. It exerts gravity the way any mass does. If our sun were somehow replaced by a black hole of the same mass, the planets would continue to orbit in much the same way, though without light and warmth. What makes Sagittarius A remarkable is not magic, but concentration. So much mass is compressed into such a small region that nearby space behaves in extreme ways. Astronomers did not first know the Milky Way's central black hole by seeing the black hole itself. Black holes do not shine ordinarily. Instead, researchers track the orbits of stars moving close to the invisible center. Those stars were whipping around something massive, dark, and compact enough to explain their motions. Over years of observation, the case became overwhelming. The hidden object at the center was best understood as a supermassive black hole. And yet, Sagittarius A is, by black hole standards, relatively quiet. It is not currently devouring matter at the furious rate seen in some active galaxies whose centers blaze across space. Our galactic black hole seems comparatively subdued, as though the Milky Way's heart is powerful but resting. From time to time, matter does fall inward, and the region around it can brighten in radio, infrared, and X-ray observations. For now, the center of our galaxy is not an all-consuming storm. It is more like a deep gravitational well in a period of relative calm. Astronomers have even created remarkable images of the glowing material around supermassive black holes, including the one in our galaxy. These images do not show the black hole itself, but the bright, ring-like emission from hot matter near the event horizon, shaped by gravity and light in ways that earlier generations could scarcely have imagined. The result is both scientific and poetic, a darkness made visible by the light, forced to bend around it. So here, near the middle of the Milky Way, we find not a throne or a jewel, but an abyss, massive beyond habit and invisible by nature. It does not ruin the calm of the galaxy. In a way, it deepens it. The center holds an unseen force around which stars wheel and time stretches into subtler forms. And still, far out in one spiral spur, our own small world continues its gentle orbit through the night. Nothing in the Milky Way is truly still. Even on the quietest night, when the stars seem pinned in place and the sky appears untouched by motion, everything is moving with patient determination. The Earth turns. The Earth circles the sun, and the sun, carrying all of us with it, moves through the galaxy in a vast orbit around the Milky Way's center. We are not parked beneath the stars. We are traveling among them, though the journey is so large and so slow that it feels, to human senses, like rest. Our solar system orbits the galactic center at a speed of roughly 220 kilometers per second. That is fast beyond everyday comprehension, fast enough to cross countries in moments, oceans in minutes. And yet, the Milky Way is so immense that even at such speed, one full trip around the center takes a very long time. This journey is sometimes called a galactic year, and for the Sun, it lasts roughly 225 to 250 million Earth years. By that measure, dinosaurs lived under a different galactic season than we do now. To say that the Sun has completed only around 20 such orbits in its entire lifetime is to feel time lengthen in a new way. Human history, all of it, agriculture and cities and ships and books and electricity and satellites and whispered lullabies, has unfolded in only the smallest fraction of one galactic year. Even the rise and erosion of mountains belongs to a rhythm much quicker than this wider turning. The galaxy does not hurry, and because it does not hurry, it teaches scale without speaking. The stars around us are moving too, each with its own path. Some drift in similar directions for a while, sharing a broad galactic flow. Others pass through with different velocities, climbing above or below the plane or tracing elongated orbits shaped by the Milky Way's gravity. Over long stretches of time, the constellations themselves change. Orion, Scorpius, Cygnus, all the familiar patterns that seem eternal are only temporary alignments from our current vantage point. Given enough time, the old shapes dissolve and new ones take their place. Even the spiral structure of the galaxy is bound up with motion. Stars closer to the center generally orbit faster than stars farther out, and yet the spiral pattern persists, not as a rigid object, but as an organized wave of density moving through the disk. Gas clouds gather, stars are born, matter moves on. The Milky Way keeps its form not by resisting change, but by composing with it. There is something deeply restful in that idea. Stability in the galaxy does not mean stillness. It means patterned motion, enduring despite change. The sun circles, the stars drift, the galaxy rotates, and somehow, within all of that movement, worlds remain coherent long enough for oceans to form, for life to appear, and for one species to look up and wonder where it is being carried. If motion gives the Milky Way its rhythm, time gives it its depth. Our galaxy is not a single-age object, born all at once and unchanged ever since. It is layered, like an old city built and rebuilt across eras, where some stones are newly set and others have endured since the earliest foundations. The Milky Way is thought to be more than 13 billion years old, meaning it formed not too long in cosmic terms, after the universe itself began. It has been gathering matter, forming stars, and evolving ever since. Some of its stars are almost unimaginably ancient. These old stars formed when the universe contained far fewer of the heavier elements we know today. Elements like carbon, oxygen, silicon, and iron. In the beginning, the cosmos was mostly hydrogen and helium. Heavier elements had to be forged inside stars and spread outward when those stars died. That means the oldest stars in the Milky Way are, in a sense, chemical time capsules. Their compositions preserve hints of an earlier universe, one not yet enriched by many generations of stellar life and death. Younger stars tell a different story. They formed later, from gas that had already been altered by earlier stars, mixed with the ash of old supernovae and stellar winds. Our sun belongs to this later category. It is not among the galaxy's first lights, but part of a later generation born from material that had already been worked upon and enriched. The iron in blood, the calcium in bone, the oxygen we breathe, all of it depends on this long history of stellar recycling. In that quiet sense, the age of the galaxy also lives within us. Astronomers think the Milky Way did not emerge fully formed in one simple gesture. Instead, it grew over time, drawn in gas, forming stars and merging with smaller systems. The inner regions may have formed early and rapidly, while the disk developed and changed across long spans of cosmic history. Even now, the galaxy remains a work in progress. Stars continue to form, though not at the frantic rate seen in some younger or more active galaxies. The Milky Way has matured, but it has not finished. A galaxy this old remembers through structure. Ancient stars are found in certain regions more often than others. Younger stars gather in the disk and spiral arms. Globular clusters preserve some of the oldest surviving populations. Streams of stars trace the remnants of smaller galaxies that were pulled apart and absorbed long ago. If you know how to read these clues, the Milky Way becomes more than a place. It becomes a biography written in light, chemistry, and motion. And that biography is still unfolding. Tonight, as we rest on a planet circling a middle-aged star, inside a galaxy that has lived for more than 13 billion years, we are suspended in one brief chapter of an immense ongoing story. The Milky Way is old enough to humble us, yet alive enough to remind us that age is not the same as ending. Among the quieter treasures of the Milky Way are star clusters, gatherings of stars that reveal something intimate about how the galaxy builds and remembers itself. Not all stars are born alone. Many begin their lives in groups, condensed from the same cloud of gas and dust, emerging together like notes from one sustained chord. Some of these groupings remain recognizable for a time, while others gradually loosen, their stars wandering apart until their shared origin becomes harder to see. Open clusters are among the gentler examples. These are relatively young groupings of stars found mostly in the galactic disk, often in or near the spiral arms where star formation is more active. They may contain anywhere from a few dozen to a few thousand stars, bound only loosely by gravity. Because their mutual grip is light, open clusters do not usually last forever. Over hundreds of millions of years, interactions with nearby clouds, with the galaxy's tidal forces, and with passing stars can gradually pull them apart. They begin together, but many do not remain together. The Pleiades, visible to the naked eye from dark places, is one of the most beloved open clusters in our sky. It reminds us that clusters need not be hidden behind large telescopes to matter. Even a small bright knot of stars can carry the story of common birth. When astronomers study such groups, they gain a useful advantage because the stars in a cluster are usually at roughly the same distance and age. Differences among them can then reveal how mass shapes stellar lives, like siblings growing in their own ways within one family. Very different are the globular clusters, which seem almost like fossils of the early galaxy. These are dense, rounded swarms containing tens of thousands to sometimes millions of stars, packed much more tightly than open clusters and often orbiting far above and below the galactic disk in the halo. Many globular clusters are extremely old, among the oldest surviving structures associated with the Milky Way. To look at one is to look into deep time, into a stellar population that has endured since near the galaxy's youth. Because globular clusters are so old, they help astronomers estimate the age of the galaxy itself. Their stars tend to be poorer in heavy elements than younger stars in the disk, marking them as relics from an earlier cosmic era. Yet they are not lifeless relics. They still move, still orbit, still hold together through gravity's patient insistence. In them, old age looks not fragile, but concentrated, as though time itself had been gathered into a shining sphere. So star clusters teach two complementary lessons. Open clusters show the Milky Way still making new stellar families in the disk. Globular clusters show it preserving ancient ones in the halo. One speaks of birth and dispersal, the other of endurance. Beyond the bright disk of the Milky Way, beyond the spiral arms and much of the gas and dust that shape the galaxy's visible beauty, there extends a more diffuse and elusive realm known as the halo. It does not announce itself to the eye the way the Milky Way's band does. It is sparse where the disk is crowded, old where the spiral arms can be active, and subtle where the galactic plane glows with obvious abundance. The stellar halo contains relatively few stars compared with the disk, but many of those stars are ancient. Their orbits are often tilted and elongated, quite unlike the more orderly circular motions common in the disk. Some sweep high above the galactic plane, then plunge back through it as though they belong to a different memory of the galaxy's past. Alongside these stars are globular clusters, also orbiting in the halo, tracing wide paths through the Milky Way's outskirts like old lanterns carried around a sleeping city. But the visible halo is only part of the story. The much larger mystery is the dark matter halo, an enormous, invisible structure thought to surround the entire galaxy and extend far beyond the luminous disk. Dark matter has never been directly seen in the ordinary sense. It neither shines nor reflects light in familiar ways. Its presence is inferred from gravity, from the way galaxies rotate, from how matter clumps on large scales, and from the fact that the visible contents of the Milky Way do not seem to provide enough mass to hold everything together as observed. One of the clues comes from galactic rotation. If only visible matter were present, stars and gas far from the center should orbit more slowly than they do, much as outer planets in a solar system move more slowly around the sun. But in galaxies, the outer regions often move faster than visible matter alone would predict. Something unseen appears to be adding gravitational support. Dark matter is the name given to that unseen influence, though its exact nature remains one of the great open questions in modern physics. There is a quiet elegance in this uncertainty. We can map the stars, measure their motions, observe gas clouds, and yet still conclude that most of the Milky Way's mass may lie in a form we do not understand. The galaxy we call home is, in that sense, only partly visible, even to our best instruments. Its lighted portion may be just the bright inner declaration of a much larger hidden structure. So when we imagine the Milky Way tonight, it helps to imagine more than the graceful band in the sky. Think also of an immense surrounding presence, sparse in stars, rich in age, and enveloped by invisible mass. The halo reminds us that what is most important in a system is not always what shines most clearly. Sometimes the deeper architecture of reality is discovered indirectly, through patience, motion, and the gentle refusal of the universe to be simpler than we hoped. The Milky Way is not alone. However self-contained it may seem when spread across our night sky, it lives in company, attended by smaller galaxies that drift nearby and over long spans of time become part of its story. Space between galaxies is vast, but it is not empty of relationship. Gravity reaches across those distances, drawing systems together, stretching them, tugging at their stars, and sometimes slowly unmaking one galaxy so that another may grow. Among the best-known companions of the Milky Way are the large and small Magellanic Clouds, two irregular dwarf galaxies visible from the southern hemisphere as detached patches of light. They are not part of the Milky Way's main band, yet they belong to its wider neighborhood and have been watched for centuries. Modern astronomy has revealed them as separate galaxies orbiting near our own, rich with stars, gas, and active regions of star formation. They are smaller than the Milky Way, but not insignificant. In cosmic terms, even companions have companions, and great galaxies often travel with retinues. The Milky Way has many other dwarf satellite galaxies as well, some obvious, many faint and difficult to detect. These systems may contain relatively small numbers of stars compared with a large spiral galaxy, but they are important clues to how galaxies assemble over time. Some are stable companions for long periods. Others are gradually pulled apart by the Milky Way's gravity. Their stars can be stretched into long streams that wrap around the galaxy, ghostly trails marking where a smaller system once moved as a more coherent whole. These stellar streams are among the loveliest forms of evidence in galactic archaeology. They show that the Milky Way has not grown only by forming stars from its own gas, but also by absorbing smaller neighbors. In the distant past, some dwarf galaxies were captured, disrupted, and folded into the halo and outer regions of the Milky Way. Their stars still travel on related paths, preserving a memory of that earlier identity. The galaxy, then, is partly an accumulation of other galaxies, gathered not in one dramatic instant, but across countless slow encounters. This process is not unusual. It seems to be part of how large galaxies in the universe mature. They merge, accrete, and reshape themselves over time. The Milky Way, though calm to our eyes tonight, bears the marks of these interactions in its halo, its streams, and the motions of its oldest stars. It is both an individual and a composite, a home built partly from what it once drew in. There is something almost tender in that. Our galaxy is not isolated perfection. It is a system formed through relationship, attraction, and incorporation. It has neighbors, companions, and a history of encounters written across its outskirts. So even at this scale, the universe is not only about distance, it is also about connection. Galaxies, like coastlines and mountains, can appear permanent when seen from the brief vantage point of a human life. But permanence in the cosmos is often only slow choreography. The Milky Way we know today was not assembled all at once, and it will not remain forever in its present form. It has changed by meeting other galaxies, by absorbing some, reshaping others and carrying their traces forward. In that sense, our home galaxy is not a single uninterrupted object, but a history of encounters made graceful by time. Astronomers have found evidence that the Milky Way merged with smaller galaxies long ago. Some of those ancient visitors were pulled apart so thoroughly that their former boundaries disappeared, leaving only streams of stars, unusual stellar motions, or subtle chemical signatures behind. The stars remain, but their original homes do not. They have been folded into the larger whole as rain becomes part of a river and can no longer be separated again. These mergers were not collisions in the everyday sense, not sudden impacts of solid bodies, but vast gravitational rearrangements unfolding over millions or billions of years. One important idea to hold gently is that galaxies are mostly made of empty space. Even when two galaxies pass through one another, individual stars are so far apart that direct star-on-star crashes are unlikely. Instead, gravity does the real work. It stretches shapes, disturbs orbits, compresses clouds of gas, and can trigger new bursts of star formation. A galactic merger is therefore less like shattered glass and more like weather, tides, and architecture all changing together on a scale too large for urgency. The Milky Way's future includes another such encounter, this time with the Andromeda Galaxy, our nearest large galactic neighbor. Andromeda is moving toward us, and astronomers expect that in roughly 4 to 5 billion years, the two galaxies will begin a long interaction that may eventually produce one larger merged galaxy. This is sometimes described dramatically as a collision, but drama is not the right mood for it. The process will unfold over an immense span of time. The night sky will slowly change. Tidal distortions will grow. Star fields will be rearranged. But the event belongs to patience, not panic. By the time this future meeting occurs, the sun itself will be much older, and Earth may already be far less hospitable than it is now. So, the coming union of the Milky Way and Andromeda is not really a threat to our daily world. It is simply the next chapter in galactic evolution, a reminder that even galaxies are not fixed monuments. They are. Within the Milky Way are not only ordinary stars and quiet clouds, but stranger things too. Objects so dense, energetic, or solitary that they seem almost like rumors hidden inside the galaxy's larger calm. Yet, even these unusual inhabitants belong to the same story. They are what become of stars under certain conditions, what remains after collapse, explosion, or ejection. The Milky Way is not merely a collection of gentle lights, it is also a museum of extremes. When a massive star reaches the end of its life, it may die in a supernova, a vast explosion that briefly outshines entire stellar neighborhoods. What remains can be extraordinary. Some dying stars leave behind neutron stars, objects so dense that a teaspoon of their matter would weigh more than a mountain. A neutron star is the compressed core of a once massive star, a place where matter has been pushed into forms almost beyond ordinary intuition. It is small in size, perhaps only about the width of a city, yet packed with immense mass. Some neutron stars become pulsars. These spin rapidly and emit beams of radiation from their magnetic poles. If those beams sweep past Earth, they can appear to pulse with remarkable regularity, like distant cosmic lighthouses. Their rhythm is so precise that pulsars helped scientists test aspects of gravity and understand stellar remnants in new ways. Even in their strangeness, they contribute to the quiet order of the galaxy, ticking through darkness with almost musical fidelity. Other massive stars leave behind stellar black holes, smaller than the supermassive one at the Milky Way's center, but still profound. These black holes may wander with companion stars, pull matter into hot disks, or move invisibly, unless their gravity reveals them. There may be millions of such black holes in our galaxy, most unseen. The Milky Way, therefore, contains hidden wells of gravity not only at its center. There is a tender irony in trying to understand the Milky Way. We live inside it, surrounded by its stars and dust, carried by its motion every second, and yet precisely because we are inside it, its full shape is difficult to see. If you stand in the middle of a forest, you can study bark, branches, leaves, and shafts of light, but not the forest's outline as easily as someone looking from above. So it has been with our galaxy. To map the Milky Way, astronomers had to become patient readers of partial clues. One of the earliest great steps came when observers realized that the pale band in the sky could be resolved into countless stars. Later, by charting the positions of star clusters and variable stars, astronomers began to estimate the galaxy's size and the sun's location within it. This was already a quiet revolution. Humanity moved from imagining itself near the center of creation to recognizing that our star lived far from the Milky Way's core, in one region among many. The galaxy became larger as we became smaller, and somehow the universe grew more beautiful for it. But visible light alone could not finish the map. Dust blocks our view, especially toward the galactic center, hiding whole regions behind dark lanes. So astronomers learned to listen in other ways. Radio astronomy revealed clouds of hydrogen spread through the galaxy, helping trace spiral structure beyond what eyes could see. Infrared observations pierced dust more effectively and exposed stars in obscured regions. X-rays and gamma rays uncovered energetic phenomena, while precise measurements of stellar motions helped reveal gravitational patterns and hidden mass. In recent years, space observatories have transformed this effort further. Missions that measure the positions, distances, and motions of enormous numbers of stars have allowed astronomers to build three-dimensional maps of parts of the Milky Way with astonishing precision. Instead of a vague galactic sketch, we now have something closer to a living survey, a portrait still incomplete, but rich with depth, motion, and structure. The map grows not from one instrument or one generation, but from many forms of seeing combined. This, perhaps, is one of the most quietly inspiring facts in the whole story. We learn the shape of our home not by stepping outside it, but by reasoning carefully from within. We listened through dust. We tracked distant stars. We measured light that the eye cannot naturally detect. We used patience where vantage was impossible. In that sense, astronomy is not only about the sky. It is about the disciplined imagination, the human ability to assemble truth from fragments. So, the Milky Way teaches not just cosmic facts, but a method of humility. We do not always get the whole picture directly. Sometimes we must infer, compare, revise, and keep looking. Long before astronomy gave the Milky Way a structure, people gave it meaning. They watched the same pale band overhead and answered it with stories, because stories were one of the oldest instruments humans possessed. Across continents and centuries, the galaxy became a river, a road, a seam, a bridge, a path for birds, a path for souls, a spill of milk, a stream of ash, a white trail left by gods or ancestors. It changed names from culture to culture, but it kept its place in the imagination as something both familiar and beyond reach. In ancient Greece, one well-known myth connected the Milky Way to divine milk spilled across the heavens, which helped shape the very word galaxy, from the Greek root for milk. Elsewhere, traditions imagined it as a road of spirits or a track through the sky used by the dead, by migrating animals, or by beings who traveled between worlds. Some indigenous traditions described it as a river or path, whose details were tied closely to local land, ceremony, and memory. The galaxy was not interpreted abstractly, it was woven into life. There is something profound in that continuity. Even when the explanations differ, the impulse is the same. Human beings look at the Milky Way and feel that it means more than a random brightness. Science does not cancel that instinct. It refines some parts of it and corrects others, but it does not remove the original feeling of significance. If anything, learning that the Milky Way is our home galaxy, made of hundreds of billions of stars and threaded with dust, gas, time, and gravity, gives the old awe a new foundation. And yet, the older stories still matter. They remind us that people were emotionally intelligent about the sky long before they were scientifically precise. They knew that darkness could hold guidance. They knew that a bright band across the heavens could orient travelers outward and inward at once. They knew that looking up changes the pace of thought. The Milky Way belonged to calendars, navigation, ritual, kinship, and quiet reflection, not only to measurement. Perhaps this is why modern people still react so strongly when they see the Milky Way clearly for the first time. Even without the old myths at hand, something older than explanation stirs. The galaxy can make a person feel small, yes, but also connected, as though some forgotten relation between self and sky has briefly returned. The effect is not purely scientific and not purely poetic. It is human. So tonight, alongside facts and measurements, it is worth keeping space for inheritance. The Milky Way is a physical galaxy. It is also a cultural companion that has traveled with our species for thousands of years. People have read it as a sign, a story, a map, and a mystery. And perhaps part of sleep's wisdom is this: not every form of understanding needs to erase the others. Sometimes knowledge grows deeper when fact and meaning are allowed to rest beside one another under the same sky. Long before astronomy gave the Milky Way a structure, people gave it meaning. They watched the same pale band overhead and answered it with stories, because stories were one of the oldest instruments humans possessed. Across continents and centuries, the galaxy became a river, a road, a seam, a bridge, a path for birds, a path for souls, a spill of milk, a stream of ash, a white trail left by gods or ancestors. It changed names from culture to culture, but it kept its place in the imagination as something both familiar and beyond reach. In ancient Greece, one well-known myth connected the Milky Way to divine milk spilled across the heavens, which helped shape the very word galaxy, from the Greek root for milk. Elsewhere, traditions imagined it as a road of spirits or a track through the sky used by the dead, by migrating animals, or by beings who traveled between worlds. Some indigenous traditions described it as a river or path, whose details were tied closely to local land, ceremony, and memory. The galaxy was not interpreted abstractly, it was woven into life. There is something profound in that continuity. Even when the explanations differ, the impulse is the same. Human beings look at the Milky Way and feel that it means more than a random brightness. Science does not cancel that instinct. It refines some parts of it and corrects others, but it does not remove the original feeling of significance. If anything, learning that the Milky Way is our home galaxy, made of hundreds of billions of stars and threaded with dust, gas, time, and gravity, gives the old awe a new foundation. And yet, the older stories still matter. They remind us that people were emotionally intelligent about the sky long before they were scientifically precise. They knew that darkness could hold guidance. They knew that a bright band across the heavens could orient travelers outward and inward at once. They knew that looking up changes the pace of thought. The Milky Way belonged to calendars, navigation, ritual, kinship, and quiet reflection, not only to measurement. Perhaps this is why modern people still react so strongly when they see the Milky Way clearly for the first time. Even without the old myths at hand, something older than explanation stirs. The galaxy can make a person feel small, yes, but also connected, as though some forgotten relation between self and sky has briefly returned. The effect is not purely scientific and not purely poetic. It is human. So tonight, alongside facts and measurements, it is worth keeping space for inheritance. The Milky Way is a physical galaxy. It is also a cultural companion that has traveled with our species for thousands of years. People have read it as a sign, a story, a map, and a mystery. And perhaps part of sleep's wisdom is this: not every form of understanding needs to erase the others. Sometimes knowledge grows deeper when fact and meaning are allowed to rest beside one another under the same sky. And now, as the story draws toward stillness, the Milky Way can be held not only as a collection of facts, but as a kind of quiet homecoming for the mind. It is a barred spiral galaxy of immense age and scale, filled with hundreds of billions of stars, stitched with dust, gas, memory, motion, and hidden mass. It contains stellar nurseries and ancient clusters, dark clouds and bright arms, the slow orbit of our sun, and the unseen gravity of a black hole deep at its center. It is not a backdrop painted behind our lives. It is the larger structure within which our lives unfold. And within that structure, our place is modest. The sun rests in a small spur of one spiral arm far from the crowded galactic center, in a region neither especially rare nor especially grand. There is something deeply calming in that fact. We do not need to occupy a special seat in the cosmos to be part of something beautiful. The universe does not diminish us by making us ordinary. In a gentler way, it includes us. We belong here not because we are central, but because we are made of the same long history of matter, time, and light. The Milky Way also teaches a quieter lesson about perspective. Almost everything in it is moving, yet the galaxy feels serene. Stars orbit, gas drifts, clusters wander. Small galaxies are drawn in and reshaped. New stars are born while older ones fade. Even the great spiral pattern is not fixed, but sustained through motion. And still, from the human point of view, the whole appears calm. Perhaps peace is not always the absence of movement. Sometimes it is movement so patient, so spacious, and so well held that it becomes indistinguishable from rest. If you were to step outside on a truly dark night, far from streetlights and windows, and let your eyes adjust, the Milky Way would not announce itself with noise. It would arrive quietly as a pale river of depth across the sky. You would be looking not at some distant abstraction, but through the disk of your own galaxy, through unresolved stars and shadowed dust, through a home so large that it can only be understood a little at a time. And perhaps that is enough. Not full comprehension, but companionship. Not mastery, but belonging. So let the facts loosen now into atmosphere. Let the scale of the galaxy become softness rather than effort. Let its old stars, hidden halo, drifting clouds, and bright central depths settle into the background of thought like distant music fading down a corridor. Above you, beyond the ceiling and beyond the weather, the Milky Way continues its long, silent turning. Around you, the room grows quieter. Within you, the mind no longer needs to travel so far. Tonight, you have wandered through our galaxy, and now you can rest inside it. Good night.